Welcome back to the Notes on Triangles. This is page 5. As we just went over, 180, I don't know why that degree sign is so low. Sorry about that. As we go back a minute, when we have the isosceles right triangle, we just pointed out that the angles are 45, 45, 90. We've got to respect that symmetry there. So most of the time we'll call it a 45, 45, 90 triangle, not necessarily an isosceles right triangle. So the second of our special right triangles, the second and the last, we only have two special right triangles. The 30, 60, 90 is referring to the angle of the triangle. Again, that 90 is our right angle. Our other two angles are a 30 degree and a 60 degree. I am going to show you very quickly how these ratios are developed, so there is no mystery here. We are going to start with an equilateral triangle. Remember that if it's equilateral, that means all three sides are the same length, and that's what we've drawn here in this triangle. When we have an equilateral triangle, we can drop the altitude, which hits perpendicular to the other side. In the case of an equilateral triangle, it cuts the angle that it's going through in half. It's an angle bisector. It's also the median. It cuts the opposite side in half. So if you look at how this triangle is labeled, we have labeled each of our sides 2s. That is not what I wanted to do. There we go. We've labeled each of our sides 2s. And so when we cut this side in half, our 2s becomes 1s and 1s because each of those pieces is the same length. Notice when we do this, we do end up with that 30, 60, 90 right triangle. Here's my 30, here's my 60, here's my 90. It's repeated in the other half. We're not necessarily worried about that. We do want to figure out how long h is, though, because if we're talking about the 30, 60, 90 triangle, we only need half of our equilateral. I have a relationship between the short side of that triangle, opposite my 30 degrees angle, and the hypotenuse opposite the 90. I need to find the length of that long leg. Okay. So we're going to use the Pythagorean theorem. My two legs are S and H. My hypotenuse is 2S. Notice that I am wrapping this in parentheses. I did not leave enough space here either. Wrapping this in parentheses before I square. I don't want to just square the S and forget to square that 2 part. Okay. I am going to subtract S squared from both sides. And we're going to move up here to where H squared equals 3 times S squared. Again, we are going to take the square root of both sides. I don't want to solve for H squared. I just want H. And I can split my 3 and S squared apart. I know I kind of bolted over that last time, so I get square root of 3 times S, the length of that shorter side. Okay, so now we're going to fill in the blank again. From this, we can conclude that the length of the longer leg is the length of the short leg multiplied by square root of 3. So just like in the isosceles right triangle, we only need one side to determine the lengths of the other two. We are going to write these ratios as x. We're going to make x my small leg, short leg. Again, x times the square root of 3, and then 2 times x. X is the shortest leg, x times the square root of 3 is the long leg, and 2x is the hypotenuse. One thing you want to remember, and this is true in any triangle, doesn't have to be just a right triangle, the shortest side is always opposite the smallest angle. So our short side will always be the side opposite our 30-degree angle. The longer leg will be opposite our 60 degrees. And of course, our hypotenuse, the longest side, is opposite our 90-degree angle.